Okay. Our next presenter is Aeriel Belk. She's a third-year PhD student in animal science. She knew she wanted to study animal science when she was showing livestock in 4-H and realized she cared more about the science behind the decisions she was making. She studies the microbiome of decomposition, both of human and food. And the title of her presentation today is The Impact of Chilling Method on the Microbiome of Chicken Breasts.
Food waste is a major problem. Globally, we waste about 1/3 of the food we produce each year. And in the United States, half of that waste is generated in the home or during distribution because the food spoils before we can consume it or sell it. One of the major drivers of food waste is bacterial growth on the product. So, one step towards resolving this problem is to try to control those bacteria and give us just a little bit more time before our food goes bad. The most widely consumed protein in the United States is chicken. So, with such a large industry, small changes can have a big impact. During chicken production, the carcasses must be rapidly cooled to below 40 degrees Fahrenheit as a food safety measure. In the United States, this is primarily done through water chilling, in which carcasses are submerged in cold water until they've reached the proper temperature. Whereas in other places like the European Union, this is done through air chilling, where carcasses are subjected to high-velocity air. There's advantages and disadvantages to both methods, but actually, much of the US industry is considering switching to air chilling to conserve resources. So, I wanted to consider the differences between these two methods and how they impact the microbial communities and spoilage patterns. To do this, I chilled 140 chicken carcasses using either air or water, then cut them into breast and placed them in dark storage for either 7 or 14 days, which mimics industry conditions. At each of those sampling points, I took a sample and measured it for the microbial community and used sensory and quality information to evaluate the spoilage conditions. I found that immediately after chilling, there were far fewer bacteria growing on the water-chilled carcasses as compared to air-chilled, which suggests that water chilling may be mechanically cleaning more bacteria from the chicken. However, by 7 days, the two methods had really similar numbers of bacteria, and the major difference was in which bacteria were growing. The water-chilled community was dominated by Pseudomonas, the major spoilage organism in meat, whereas the air-chilled community was much more diverse. This suggests that by removing the competition early on, the water-chilled carcasses could reach spoilage faster, a fact that was backed up by our quality and sensory data. By the end of 14 days, everything was spoiled and everything was dominated by Pseudomonas. This led me to conclude that water chilling may be pushing the microbial community towards a spoilage state faster than air chilling. Therefore, by switching the US industry to air chilling, we may gain just a little bit more time to eat our product, therefore taking a bite out of the food waste problem. Thank you.